Okay, this is a third set of atomic structure questions, all multiple choice, all past paper from AQA A-level chemistry. Have a look at the question, pause it when you've got an answer, carry on working through the video to see if you got it right, and see if there's any areas that you maybe then need to revisit and revise a little further. So, starting with a relatively straightforward one here, which of these has the highest first ionization energy? I'm going to put the graph in that we need to remember. We need to know that there is a general increase in first ionization energy, and we need to know where there are the two dips and the reasons behind them. But for this question, we're simply looking at the fact that there is a general increase of the four that are there. Chlorine is the highest. And so we have our correct answer. This question relies on you remembering quite a lot of key information, not just from this topic. So let's go through and see precisely what steps you would need to go through to be able to answer it. To begin with, you have to know that a sulfate ion has a charge of -2. Now you can remember that by considering H2SO4 is 0 and hydrogen forms +1 ions. So from there, if SO4 is -2 and the formula is QSO4, Q must be +2. Now from there, we can take that a step further forward and we can say that Q forming a +2 ion is likely to be group 2. So we are looking for something that ends with an S2 in the electron configuration. And that takes us to answer B. So this links a little bit with our knowledge of alkanes as well. CH3 as a radical, we need to know that it has 6 electrons in the carbon. There are 3 hydrogens, each with 1 electron. That's 9 electrons in total. So we're looking for another one of these that will have 9 electrons. Now, if I look at CH2, I've got 6 in the carbon, 2 in each of the H's, so I've got 8. If I consider CH3+, that would be 9 in the CH3, but it's positive, which means it's lost an electron, which means that's also 8. CH3-, well, I've got 9 in a CH3, so minus we add 1 and we get to 10, and that therefore leaves us with CH4+. CH4, 6 in the carbon, 4 hydrogens, that's 10 electrons in total, but the positive charge means we've lost 1, so we have 9, which is the same as CH3, and there we have our answer. So we have got A, B, C and D, AR, CL, MG and NA. That's going right to left on the periodic table. We want to know which of these has the largest atomic radius. You have got to remember that atomic radius decreases as you go across a period. That's because there's an increased nuclear charge and there is no increase in shielding. So purely on that basis, we can see that sodium is the correct answer. Onto an isotopes question now. We need to know which of the 4 statements is correct. So let's take a look through each of them. The ions of both the isotopes have the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now it would be very easy to look at that and think, well, they're the same charge, so they do have the same electron configuration. That's true. But it hasn't taken into account the fact that we empty 4s before we empty 3d. So though they will both have the same electron configuration, that electron configuration is not what's in A. Moving on now to B. Isotopes of both the isotopes, or ions of both isotopes, contain 26 neutrons. Well, the key differences between isotopes of the same atom are the number of neutrons and mass number, so that cannot be the case. Will an ion 2 with 53 mass number have fewer protons? No, protons actually determine what the atom is. So iron will always have the same number of protons. So that then takes us to D. After acceleration to the same kinetic energy, the 56 will move more slowly than 53. Yes, this is true. If they both have the same kinetic energy, the larger of the two isotopes will move more slowly. Now, there are more complicated versions of this question that actually ask you to work out the ratios of the peak heights. But for this one, we simply want to know how many different variations can there be combining chlorine-35 with chlorine-37. And we can put a 35 with a 35, a 35 with a 37, or a 37 with a 37. So the correct answer is B. There is some maths involved on this question, and you should be using the periodic table. I've taken the relevant atoms and put those on here so we can actually do the maths with the numbers directly. So, uranium, mass number 234, atomic number is 92, would have 142 neutrons. When I do the same with lithium, 6 take away 3 is 3, helium, 3 take away 2 is 1, and hydrogen, 2 take away 1 is 1. There is only one example here where the number of protons, the atomic number, is bigger than the number of neutrons. Correct answer is C. Okay, assuming that chlorine exists as two isotopes, they are 35 and 37, as I'm sure you know, and that hydrogen and carbon only exist as one isotope, how many different molecular ion peaks would be shown in this mass spectrum? Crucially, this has got 4 chlorines in it. So what we've got to do is work out how many different variations there can be. And I could have 4 35s. I could have 3 35s with a 37, 2 35s, 2 37s, 1 35 with 3 37s, or 4 37s. Remember, it doesn't matter about the position of the 35s or the 37s here. We simply want to know how many peaks there would be. So the correct answer is 5. So this is telling us boron does have a lower first ionization energy than beryllium. The question here is actually why. So I've put the graph up again so we can see it's exactly the same graph as we use in period 3, sodium across to argon. So it parallels over perfectly. We can see the dip at boron, we can see the dip at oxygen. Once we can see where that dip is and where we are looking, we can see that it's happening as we move in to the 2p sublevel. So the fact that the electron is being removed from a higher energy p sublevel means that less energy needs to be put in, so the ionization energy drops. So here we're now considering comparisons of ionization energies for X and Y, and we want to know where the ionization energy of Y would be higher than X. Let's go through and take a look at what's happening. In C, we are seeing spin-spin repulsion in the 2p sublevel. There are 2 electrons sharing an orbital. So for that reason, the answer is not C. In D, we are moving into a higher principal energy level, so you are going to expect there to be a dip. And in B, you are moving into a higher energy 2p sublevel, which means that you have to put less energy in. So all 3 of those are going to lead to a decrease in first ionization energy. But in this case, in A, there is an increased nuclear charge because there's an extra proton, but there is no increase in shielding. So for that reason, the correct answer is A.